Hello, friend. Welcome back. Or if this is your first time here, welcome home. Tonight we're going somewhere quiet, somewhere endless, somewhere that's been waiting for you. Some nights the sky feels closer than it should. You look up and the stars seem to breathe, pulsing, ancient, alive. And somewhere in the back of your mind, a question forms, a soft, curious whisper. If a star exploded right now, millions of miles away, bursting with the force of 1 billion suns, sending light racing across the darkness, would you hear it? Would the universe scream? Or would it all happen in perfect absolute silence? The answer might surprise you. Because out there in the vast cathedral of space, the most violent events in existence unfold without a single sound. Galaxies collide, stars die. Black holes devour everything around them, and yet there's no roar, no echo, no whisper, just silence. The kind of silence so complete, so profound, that it feels almost alive. Before we drift further into this quiet mystery, I want to invite you to stay a while. If these gentle journeys through science bring you peace, you might like to tap the like button below. Subscribe if you'd like more nights like this one. And ring the little bell, not for noise, but so the next quiet story can find you again when you need it most. No pressure, just an invitation. You're always welcome here. Now, let's drift. Tonight we are exploring something strange, something beautiful, something that feels wrong at first until you understand it. We're walking into the silence of space, the silence that fills everything, the silence that in a way makes us possible. You don't need to understand it all right away. Just rest. Let curiosity do the listening, and we'll wander together through the quietest place that's ever existed. The universe is loud. That's the strange part. It's bursting with energy. Exploding stars, colliding worlds, shock waves rippling through clouds of gas. Scientists have measured these events. They have calculated the forces involved. A supernova, for instance, releases more energy in a few seconds than our sun will produce in its entire lifetime. 10 octillion watts of power. That's a 1 with 28 zeros after it. Incomprehensible. If that happened here on Earth with our atmosphere to carry the sound, you wouldn't just hear it. You'd feel it in your bones. The air itself would shatter. But out there, in the vacuum between stars, nothing. Not a whisper. It feels wrong, doesn't it? We're so used to explosions being loud. Fireworks crack the sky. Thunder rolls across hills. Even a balloon popping makes us jump. Our brains connect violence with sound, action with noise. But space refuses to cooperate. It holds all that energy, all that chaos, and keeps it perfectly, impossibly quiet. Picture this. You're floating out there. No spacecraft. Just you somehow surviving in the void. Protected, let's imagine by some perfect suit. You turn your head and watch a star go supernova, right there. Close enough to see the shockwave expanding. Close enough to see light bending around the collapsing core. The brightest thing you've ever witnessed. Brighter than 1,000 suns. Brighter than anything humans have words for. And you hear absolutely nothing. Your heartbeat maybe, your breath inside the helmet, but from the star silence. The kind of silence that presses against your ears, the kind that makes you wonder if you've gone deaf. You haven't. The universe hasn't broken. This is just how things are out there. This is the nature of the place we came from. Some scientists suggest this silence is one of the universe's oldest truths, older than stars, older than galaxies. When the cosmos was young, just after the Big Bang, it was dense enough that sound waves could travel. Pressure waves moved through the hot plasma, creating what researchers now call the cosmic microwave background. But as space expanded, as everything spread apart, the medium disappeared, and with it, so did the possibility of sound. The universe grew into its silence. It wasn't always this way, but it became this way. And now, 13.8 billion years later, silence is the mother tongue of everything. Here's something that might help you feel the strangeness. Think about Earth. Right now where you are, there are about 10 billion trillion molecules of air in every cubic centimeter around you. 10 with 19 zeros. They're bouncing off each other constantly, vibrating. When something makes a sound like a voice or a guitar string, it disturbs these molecules. They bump into their neighbors. Those neighbors bump into theirs. And that cascade of tiny collisions travels to your ear as sound. It's a dance. Molecule passing energy from one to another. Like a crowd doing the wave in a stadium. Each person only moves a little, but the wave travels far. Now picture space, deep space, the kind between galaxies. In that same cubic centimeter, there's about one atom, maybe, sometimes less. Sometimes you'd have to search a volume the size of a house to find a single particle. One atom can't do the wave. It can't pass the message along. There's no one to pass it to. The stadium is empty. The dancers have gone home. That's why space is silent. Not because sound doesn't want to travel, but because there's nothing to carry it. No medium. No molecules holding hands passing vibrations forward. It's the loneliest kind of quiet. The ancient Greeks wondered about this. Aristotle believed that nature abhors a vacuum. That empty space simply couldn't exist. Something he thought must always fill the gaps. For centuries, people agreed. They invented ideas like the ether, an invisible substance that filled the cosmos. They needed something out there, some medium for light, for gravity, for the motions of planets. But nature didn't care what Aristotle believed. The vacuum existed anyway, perfect and patient and waiting to be understood. In 1660, an English scientist named Robert Boyle performed an experiment that changed everything. He placed a ticking pocket watch inside a glass jar. Then slowly, carefully, he pumped the air out. As the air thinned, the ticking grew fainter, softer, until finally, even though the watch was still moving, still keeping time, still vibrating, the sound disappeared completely. The watch didn't break. It was still screaming in its small, mechanical way. But there was no one to carry the message, no air to dance the vibrations forward. Boyle had created a tiny piece of space right there in his laboratory. And in doing so, he proved what the universe had known all along. Silence isn't the absence of noise. It's the absence of a messenger. That experiment echoes through history. It whispers to us even now. Because every time we launch something into space, every time we send astronauts beyond our atmosphere, we're sending them into Boyle's jar, into a place where their voices can't travel, where explosions make no sound, where the universe keeps its secrets quietly. Think about the moon landing. 1969. Neil Armstrong stepping onto the gray dust. Buzz Aldrin following. Millions of people watching on television, hearing their voices crackle through the radio. But out there on the lunar surface, when they moved their boots crunching regolith, when they planted the flag, when they bounded across that alien landscape, the moon itself heard nothing. No footsteps, no breath, no words. Everything they said to each other traveled through their radios, through electrical signals, through technology designed to replace what nature wouldn't provide. They could have been shouting or whispering. It wouldn't have mattered. The moon doesn't have ears. And even if it did, there's no air to carry the sound from their helmets to the ground. They walked through silence so complete, it would drive some people mad. And yet, something beautiful happens in that silence. Something worth noticing, because when you take away sound, you're left with everything else. Light becomes more vivid, colors feel richer, the texture of existence sharpens. Astronauts often talk about this. They describe looking at Earth from orbit, seeing the blue curve against the black nothing, and feeling overwhelmed, not by noise, but by presence, by the weight of vision without distraction, by seeing the world as it is unaccompanied by the soundtrack we always imagine should be there. Chris Hadfield once said that spacewalks are the quietest moments of his life. Floating outside the International Space Station, tethered by a single cable, surrounded by the machinery of survival, but hearing only his own breath. He described it as peaceful, profoundly peaceful, like meditation forced upon you by physics. Because in that silence, you're alone with yourself in a way that's impossible on Earth. There's no traffic, no wind, no birds or voices or music bleeding through walls. Just you, your heartbeat, your thoughts, the universe watching, saying nothing. Is that terrifying, or is it a kind of freedom? Maybe both. Maybe that's the point. Here's a question for you softly. No need to answer aloud. Just wonder about it as you drift. If you could float out there just for a moment, suspended in that perfect quiet, would you want to? Would you want to experience the silence that astronauts describe? Or does the idea feel too lonely, too far from everything that makes you feel human? There's no wrong answer, just curiosity. Because the silence of space isn't cruel. It's not trying to isolate us. It's simply the truth of the medium, or rather the truth of the lack of medium. And in understanding that truth, we learn something about sound itself, about what it needs, about what it is. Sound is connection, molecule to molecule, particle to particle. It's matter touching matter, passing energy forward. And space, for all its violence and beauty, for all its stars and storms, is too empty for that connection to happen. It's the loneliest sound you'll never hear. The scream of a supernova, the collision of galaxies, the whisper of solar wind brushing past a distant comet. All of it happening. None of it heard. Unless, of course, we find a way to listen differently. Unless we learn to translate what the universe is saying into something our ears can understand. And that's exactly what we've done, in ways stranger and more beautiful than you might imagine. But we'll drift into that part of the story soon. For now, rest in this truth. Space is silent, not because nothing is happening, but because silence is the language of vastness, the dialect of distance, the choice the cosmos made when it decided to grow. Light can cross the void, gravity can reach across galaxies, but sound needs neighbors. And out there between the stars, there are no neighbors close enough to hear. So the universe keeps its violence to itself. Its storms rage without thunder. Its fires burn without crackle. And somewhere in all that quiet, we learn to float, to breathe, to wonder what we're missing. You don't need to be afraid of the silence. It's been there longer than we have. It'll be there long after. And in a strange way, it's protecting us. Because if we could hear everything happening out there, the roar would be unbearable. Every star burning, every particle colliding, every wave of radiation sweeping past. It would deafen us, shatter us. Instead, the universe gives us quiet. It gives us space to think, to dream, to listen to the smaller sounds, the ones that matter. Your breath, a heartbeat, a voice saying softly that you're not alone. Even in the silence, especially in the silence, you're never truly alone. But if sound can't exist out there, what about the things we've heard? The strange hums and pulses that scientists have recorded? The so-called music of planets and stars? That's where things get interesting. Because the universe may be silent, but it's not voiceless. We've just had to learn a different way to listen. Sound is a miracle we take for granted. Every word you've ever heard, every song that's moved you, every laugh from someone you love. All of it depends on something so simple we forget it's even there. Air, molecules, matter pressing against matter, carrying vibrations forward like a secret passed from friend to friend. But what happens when there's no one left to pass the secret to? What happens when the molecules disappear and the dance stops and all that's left is empty space? That's the question that haunted scientists for centuries. And the answer reveals something beautiful about the very nature of sound itself. In 1660, a man named Robert Boyle sat in his laboratory in Oxford, England, staring at a glass jar. Inside that jar was a small brass bell suspended by a thread ticking quietly. Boyle was curious, obsessively curious. He'd heard the ancient arguments, Aristotle's insistence that nature abhors a vacuum, the medieval certainty that emptiness simply couldn't exist. But Boyle wondered, what if it could? What if you could remove the air from a space and see what happened? Not to philosophy, not to theory, but to something real, something you could hear. So he built a pump, primitive by modern standards, but effective. Slowly, carefully, he began pulling air from the jar. And as he did, something remarkable happened. The bell kept ringing, the mechanism kept moving, but the sound grew fainter, softer, like a voice calling from farther and farther away. When the air was nearly gone, the bell fell silent, completely silent, even though Boyle could see it still vibrating, still moving, still trying to ring. The bell hadn't stopped working. The universe hadn't changed its laws. But without air to carry the vibrations, the sound had nowhere to go. It died in the space between the bell and the glass, trapped, voiceless. Boyle had proven something profound. Sound isn't a thing. It's a relationship, a conversation between matter and matter. Take away one side of that conversation, and silence is all that remains. Scientists today would explain it differently with more precision, but the truth is the same. Sound is a mechanical wave. It needs a medium, something physical to travel through. Air works beautifully. So does water. So does steel or wood or even the ground beneath your feet. But empty space offers nothing. No molecules to bump, no particles to vibrate, no dance partners at all. Think about it this way. When you speak, your vocal cords vibrate. Those vibrations push against the air molecules in your throat. Those molecules push against the ones next to them, and those push against the next ones. And on, a cascade of tiny collisions spreading outward in all directions. By the time that wave reaches someone's ear, the original molecules from your throat are still in your throat. They haven't traveled anywhere. They've just nudged their neighbors. But the energy has traveled, the pattern has moved. And when it reaches an eardrum, that pattern makes the drum vibrate. And the brain interprets those vibrations as sound, as meaning, as a voice. It's elegant, efficient, and completely dependent on having neighbors close enough to nudge. On Earth at sea level, there are approximately 25 quintillion molecules in every cubic inch of air. That's 25 with 18 zeros. They're packed so tightly that each molecule collides with its neighbors billions of times per second. Sound moves through this crowded space at about 767 miles per hour, fast enough to seem instant. Slow enough to create echoes delays the richness of acoustics in a concert hall. But step outside our atmosphere and everything changes. The International Space Station orbits about 250 miles above Earth. Up there, the air is so thin, it barely exists. Maybe a few thousand molecules per cubic inch. Not enough to carry sound, not even close. Go farther, deep space, the kind between stars. In that same cubic inch, you might find one molecule. Maybe, if you're lucky. And that molecule might not encounter another one for hours, days, longer. One molecule can't carry a wave. It can vibrate, it can move, but there's no one nearby to receive the message. The wave dies before it begins. That's why astronauts, even when they're inches apart during a spacewalk, can't hear each other without radios. The vacuum between them swallows every sound. Their voices vibrate their helmets. Those vibrations turn into electrical signals. Those signals travel as radio waves, which don't need air, and get converted back into sound inside the other person's helmet. It's a strange detour. Voice to vibration, to electricity, to radio, to electricity, to vibration, to voice. All to cross a gap of a few feet. But it works. Because humans, stubborn and clever, refuse to accept silence when they want to talk. Here's something that surprised early researchers. Sound doesn't travel the same speed through everything. In air, as we said, it's about 767 miles per hour. In water, it's nearly 4 times faster, close to 3,400 miles per hour. In steel, faster still, over 13,000 miles per hour. Why? Because it's all about how tightly the molecules are packed and how easily they transfer energy. water molecules are closer together than air molecules. Steel atoms are closer still. The tighter the crowd, the faster the nudge can travel. But in space, there is no crowd. There's barely a molecule within shouting distance. So, the speed of sound becomes irrelevant. You can't measure the speed of something that can't travel at all. It's like asking how fast a letter moves when there's no postal service. The question doesn't make sense. The system doesn't exist. And yet we imagine it does. We imagine space is loud, roaring with engine burns and explosions and laser blasts. Every science fiction movie you've ever seen has lied to you about this. And beautifully so. Because silence, real silence, doesn't make for dramatic cinema. When the Death Star explodes in Star Wars, you hear a thunderous boom. When the Enterprise fires photon torpedoes in Star Trek, there's a satisfying whoosh and crack. When spacecraft dogfight in Battlestar Galactica, engines scream and metal groans. None of it would make a sound. Not in the real vacuum of space. The explosions would bloom silently. The engines would burn without roar. The collisions would crumple metal in perfect, eerie quiet. Directors know this. They choose sound anyway, because humans need sound to feel emotion. We connect noise with action, silence with stillness. A silent explosion feels wrong, even though it's right. So movies give us what we need emotionally, not what's true physically. And honestly, that's fine. Fiction is allowed to lie, as long as we remember it's fiction. But here's where it gets interesting. Scientists have wondered, what if? What if space wasn't a vacuum? What if somehow the void between planets was filled with air thick and breathable like Earth's atmosphere? If that were true, if space had air, could we hear the sun? The answer is yes. And it would be unbearable. Researchers have estimated that if the sun were surrounded by an atmosphere like Earth's, and if that atmosphere extended all the way to our planet, the sound of the sun's surface would reach us at about 100 decibels. That's as loud as a jackhammer, a rock concert, a chainsaw, constant, unending, day and night. A roar from 93 million miles away, loud enough to damage hearing over time. We would never know true quiet. The sun would hum in our ears from birth to death. A low rumbling drone, the sound of fusion, of plasma convection, of a star burning hydrogen into helium, spilling energy into the void. But space is a vacuum, so we're spared. We live in the sun's light, but not its noise. We feel its warmth, but not its voice. Silence in this case is a gift, a kindness from physics. Think about what that means. Every star in the night sky is screaming, burning, exploding with energy. But because the space between us and them is empty, we see them in perfect silence. We get the beauty without the noise, the light without the roar. It's like watching fireworks through soundproof glass. You see the colors bloom and fade, you see the sparks scatter, but you don't hear the bang. And somehow, that makes it more peaceful, more meditative. The universe gives us a light show every night, free of charge, free of sound. Maybe that's why we find the stars so calming. Why we look up on clear nights and feel something loosen in our chests. The sky is busy, full of violence and energy and constant change. But it's wrapped in silence, and that silence makes room for our own thoughts, our own quiet. Have you ever stood outside on a winter night when the air is cold and still and just looked up? No music, no cars, just you and the stars and the soft crunch of snow under your boots. That's as close as most of us get to the silence of space. A silence that isn't empty, that's full of presence, full of light and time and distance, but empty of sound. It's humbling, in the best way. Now, here's something you might not have considered. Sound as we experience it is a human invention, not the physics of it. The physics are universal, but the interpretation. That's all us. A tree falls in the forest. No one's around. Does it make a sound? The old philosophical riddle. Physics says yes. the tree hits the ground. The impact sends vibrations through the air. Those vibrations exist whether anyone hears them or not. But sound, the subjective experience of sound, the thing we call hearing, requires an ear, a brain, an observer to turn vibrations into perception. Without ears, there are only vibrations. Pressure waves moving through a medium, no music, no noise. Just physics doing what physics does. Space is like that forest, full of vibrations that never become sound because there's no medium to carry them. And even if there were, there's rarely anyone around to listen. The universe doesn't care if we hear it. It's not performing for us. It's just existing indifferent and vast, following the rules it set for itself long before we arrived. And yet, we want to hear it, desperately. We want the stars to have voices, the planets to hum, the cosmos to sing. So, we found a way, not by changing space, but by changing how we listen, by translating what space does offer into something our ears can understand. Because space may not have sound, but it has plenty of other things. Radiation, electromagnetic waves, plasma vibrations, magnetic fields oscillating at frequencies we can't hear but can measure. And if we're clever, if we're patient, we can turn those invisible waves into audio. We can give voice to the voiceless, not because space is speaking, but because we've learned to interpret its silence. It's a kind of translation, like turning a book written in a language you don't know into one you do. The original text hasn't changed, but now you can understand it. Now it can reach you. That's what scientists have been doing for decades. Listening to space not with ears, but with instruments, and then carefully, lovingly turning what they find into sound. The results are haunting, strange, beautiful in ways that feel almost alien. Because in a sense, they are alien. They're the universe speaking in a language it never intended to speak. A language we gave it so we could feel less alone in the quiet. Emptiness is harder to imagine than you'd think. We live our entire lives surrounded by something. Air presses against our skin, water fills our cups. Even the spaces between objects in a room are crammed with molecules we can't see but can't escape. True emptiness, the kind where nothing exists, not even a single atom, feels impossible, unnatural, wrong. And yet, that's what most of the universe is. Not stars, not planets, not clouds of glowing gas, just emptiness. Vast, patient, and so complete it makes the word empty feel inadequate. Space isn't just empty. It's profoundly, almost violently empty. And that emptiness is exactly why silence reigns. The ancient Greeks couldn't accept it. Aristotle, one of the greatest minds of his time, declared with absolute confidence that nature abhors a vacuum. He believed the universe was full, packed tight with invisible substance. Because how could nothing exist? How could there be a place where truly nothing was? For nearly 2,000 years, people believed him. They had to. The alternative was too strange, too uncomfortable. Medieval philosophers built entire systems of thought around the idea that emptiness was impossible, that God or nature or the fundamental order of things wouldn't allow it. But the universe doesn't care what makes us comfortable. It's been empty for billions of years, and it's perfectly fine with that. When Galileo and later scientists began studying the heavens with telescopes, they started to suspect the truth. The spaces between celestial bodies seemed to contain nothing. No air, no water, no ether, despite what many still hoped. Just distance, just void. It took until the 17th century for anyone to prove it. Evangelista Torricelli, a student of Galileo, created the first sustained vacuum in a laboratory. He filled a glass tube with mercury, sealed one end, and inverted it into a dish. The mercury fell slightly, leaving an empty space at the top of the tube. A space that contained nothing, no air, no substance of any kind. People called it Torricelli's vacuum, and it terrified them. Because if emptiness could exist in a tube, then maybe it existed out there too, in the vast darkness between worlds. They were right to be unsettled. Because the vacuum of space isn't like the vacuum in a laboratory. It's bigger, deeper, more absolute than anything we can create on Earth. Even our best vacuum chambers, the ones used by scientists to simulate space, still contain traces of air. Billions of molecules per cubic inch. It sounds like a lot. And compared to true space, it is. In low Earth orbit, where the International Space Station floats, there are only about a few million molecules per cubic inch. That's a billion times less dense than the air you're breathing right now. Sound can't travel there. The molecules are too far apart. They bump into each other occasionally, but not often enough to carry a wave. Go higher, to the space between Earth and the Moon. The density drops even further, maybe a few thousand molecules per cubic inch. Then a few hundred, then a few dozen. By the time you reach the space between planets, what scientists call interplanetary space, you're down to about 10 particles per cubic inch. 10, in a volume the size of a sugar cube. Imagine that. A cube of space the size of something you'd put in your coffee, and inside it floating alone are 10 atoms, hydrogen mostly. Maybe a stray helium nucleus. Each one separated from its neighbors by distances that, on an atomic scale, might as well be miles. Those atoms aren't standing still, they're moving, zipping around at thousands of miles per hour, leftover energy from the solar wind or some ancient stellar explosion. But they almost never collide. Space is so empty that an atom can travel for hours, days without encountering another one. That's not a medium, that's barely anything at all, and it gets emptier. Between star systems in what's called interstellar space, the density drops to about 1 atom per cubic inch, sometimes less. Sometimes you'd have to search a volume the size of a refrigerator to find a single particle. One atom can't do much. It can't carry sound. It can't form a wave. It just drifts alone, surrounded by nothing, waiting for something that might never come. This is the universe's default state, not fullness, emptiness. The stars and planets and galaxies, all the matter we can see, they're the exceptions. The rare spots where stuff happens to clump together. Everything else, the vast majority of existence, is void. Scientists estimate that if you took all the matter in the observable universe and spread it out evenly, you'd have about 1 hydrogen atom per cubic meter. 1 atom in a space the size of a small closet. That's how empty space really is on average. But even that's not the emptiest it gets. Between galaxies and the intergalactic medium, the density drops even lower. 1 atom per 10 cubic meters, maybe 1 per 100. These are regions so empty that calling them space almost feels generous. They're less than space. They're the ghost of space, the memory of existence. If you could somehow exist there, floating in that darkness, the nearest galaxy might be millions of light years away. The nearest star farther than your mind can comfortably hold. And around you in every direction, just emptiness. Perfect. Silent. Endless. No sound could travel there. Not because sound is forbidden, but because there's nothing to carry it. You could scream with the force of a supernova, and the vibration would die at your lips. The few atoms nearby might jiggle slightly, but the wave wouldn't propagate. It wouldn't spread. It would just stop. That's the vacuum. Not just the absence of air, the absence of almost everything. And here's the beautiful, terrible part. That vacuum is stable, permanent. It's not going to fill in. There's no cosmic wind rushing in to equalize the pressure, because there's no pressure to equalize. Space has been this empty for billions of years, and it will stay this empty for billions more, unless of course you're near something, a star, a planet, a nebula. Then things get interesting, because while space itself is a vacuum, the stuff in space sometimes isn't. Around our sun, for instance, there's a constant stream of particles called the solar wind. Charged protons and electrons blown outward by the sun's heat and magnetic fields. It's not dense, not by Earth standards, but compared to the emptiness beyond, it's practically crowded. Millions of particles per cubic inch rushing past Earth at hundreds of miles per second. That's still not enough for sound. Not traditional sound. But it's enough for something else, something stranger. Vibrations in plasma, oscillations in magnetic fields, waves that don't move through air but through ionized gas and electromagnetic force. Scientists call these plasma waves. And while they're not sound, not exactly, they behave similarly. They have frequency, amplitude, they can be measured and recorded. And with the right equipment, they can even be translated into something we can hear. But we'll come back to that. For now, just sit with the emptiness. Feel how strange it is, how wrong it seems even though it's the most natural thing in the universe. We evolved in density, in air thick enough to breathe, water deep enough to swim, forests packed with trees and soil rich with roots. Everywhere we looked, there was something. Matter pressing against matter, sound traveling freely, connection happening constantly. So, when we imagine space, we imagine it like Earth, just darker, colder. We forget about the emptiness. We picture astronauts floating near ships, planets looming, close stars scattered like sand on a beach. But the reality is so much emptier. The distances are so much vaster. If you scaled the solar system down so that Earth was the size of a peppercorn, the Sun would be a beach ball 8 feet away. Jupiter would be 50 feet away. Neptune over 200 feet. And that's just our solar system. One tiny neighborhood in one galaxy. The space between stars is incomprehensibly larger. Proxima Centauri, the nearest star to our Sun, is about 4 light years away. If you kept that same scale where Earth is a peppercorn and the Sun is 8 feet away, Proxima Centauri would be over 1,000 miles away. 1,000 miles of empty space. No planets, no asteroids, nothing but void and the occasional lonely atom. And between galaxies, forget the scale. It doesn't fit in metaphors anymore. It just becomes numbers too large to feel. That emptiness is why the universe is silent. It's not a bug, it's a feature. Space is supposed to be empty. That's what allows galaxies to move, stars to form, light to travel unimpeded across billions of years. If space were full, if it were packed with air or water, or any substance dense enough to carry sound, everything would slow down, grind to a halt. The friction would be enormous. Stars would burn differently. Planets wouldn't orbit cleanly. Light itself would scatter and fade. The vacuum isn't a problem to be solved. It's the solution. It's what makes the universe work. But it does create a profound kind of loneliness. Because in all that emptiness, events happen that no one hears. Catastrophes unfold in silence. Beauty blooms without witness. A star dies. Its outer layers blow away in a shell of expanding gas. The core collapses. Neutrinos flood outward. Light erupts. And through it all, not a sound. Just the silent fury of physics doing what it does best. 2 black holes spiral toward each other. They've been falling for millions of years, locked in gravitational embrace. Closer and closer, faster and faster. And then finally, they merge. Space itself ripples. Gravitational waves spread outward at the speed of light. But sound nothing. The most energetic collision in the universe, and it happens in absolute quiet. It's humbling to realize that the cosmos doesn't perform for us, doesn't announce itself, just exists indifferent to whether we notice. And yet, in that indifference, there's a kind of peace. Because the silence isn't hostile. It's not trying to keep us out. It's just the natural state of a universe that's mostly nothing. We're the odd ones, the exception, living on a wet rock with an atmosphere thick enough to carry our voices, swimming through air dense enough to let us hear music and laughter and rain. We're the noisy corner of an otherwise silent existence. And maybe that's exactly as it should be. But the vacuum isn't entirely empty. That's the thing scientists keep discovering. Even in the darkest voids between galaxies, there's always something. A quantum fluctuation, a stray photon, a whisper of dark matter passing through invisible and undetectable except by its gravity. The universe may be mostly empty, but mostly isn't the same as completely. And in those tiny exceptions, those rare places where particles gather, something almost like sound can begin to exist. Imagine standing at the edge of possibility, where silence meets something that's almost not quite but nearly sound, where the rules bend just enough to let vibrations exist, even if no ear could ever hear them. Space isn't as silent as we thought, not completely, not everywhere. In certain rare pockets under certain strange conditions, the universe creates something that trembles on the edge of being sound, something that waves, something that pulses, something that, if you translated it carefully, sounds like the universe humming to itself in the dark. These aren't sounds, not technically, but they're close enough to make you wonder. The sun doesn't burn the way a campfire burns. There's no oxygen out there, no combustion. Instead, deep in its core, hydrogen atoms slam together under crushing pressure and heat fusing into helium. This releases energy, enormous amounts of energy. And that energy doesn't just radiate outward as light. It churns, it boils. It creates movement in the sun's plasma, the electrically charged soup of particles that makes up most of the star. Plasma is strange stuff. It's the fourth state of matter after solid, liquid, and gas. Strip electrons away from atoms, and what's left is a sea of charged particles, positive nuclei and negative electrons, all mixed together but not quite touching. Lightning is plasma. Neon signs are plasma. N-stars are almost entirely plasma from core to corona. In plasma waves can travel. Not sound waves, not exactly. But something similar. Oscillations in density and pressure, ripples in magnetic fields. Scientists call them magnetohydrodynamic waves, which is a beautiful, complicated way of saying the plasma can vibrate. These vibrations don't need air. They need charged particles and magnetic fields, both of which the sun has in abundance. So the sun hums, it vibrates. It rings like a bell, its surface rising and falling in patterns that repeat every 5 minutes or so. Astronomers discovered this in the 1960s. They were measuring the sun's light, looking for tiny shifts in wavelength, when they noticed something odd. The surface of the sun was moving, pulsing. Different regions rising and falling at different rates, creating a complex overlapping pattern of vibrations. They called it helioseismology, the study of sunquakes, and what they found was astonishing. The sun isn't just a static ball of fire. It's alive with motion. Waves crisscross its surface. Pressure pulses travel through its interior. The entire star resonates like a drum being struck over and over by invisible hands. If you could somehow hear those vibrations, if you could translate them into frequencies, our ears understand the sun would sound like a deep rumbling drone. A chord made of thousands of overlapping tones. Some scientists have done exactly that, taken the data from helioseismology and converting it into audio. The result is eerie, unsettling, a sound that feels ancient and alien because it is. But here's the important part. Those vibrations aren't traveling through space. They're happening inside the sun and its plasma. Space itself remains silent. The vacuum between the sun and Earth carries light, carries radiation, carries the solar wind, but not sound, never sound. Still, it's closer than anything we've talked about so far. Plasma waves are mechanical. They move through matter. They compress and stretch and propagate. If space were filled with plasma instead of vacuum, those waves could travel. They could reach us. But space isn't filled with plasma, mostly, except when it is. The solar wind isn't just particles flying outward, it's plasma. Ionized hydrogen and helium, streaming away from the sun at hundreds of miles per second. And within that, plasma waves can exist. Researchers have measured them. Oscillations in density, fluctuations in magnetic field strength, pulses that travel through the charged particles like ripples on a pond. These plasma waves carry energy. They can accelerate particles. They can interact with planetary magnetic fields. And in some rare cases, they can create what's called a bow shock. Picture this. Earth sits in the path of the solar wind, a constant stream of charged particles rushing toward us at incredible speed. But Earth has a magnetic field, a protective bubble that surrounds the planet. When the solar wind hits that magnetic field, it doesn't just pass through. It piles up. It compresses. It forms a shock wave like water hitting the bow of a ship. That shock wave is a real physical boundary, a place where the solar wind suddenly slows down and heats up. And within that shock, plasma waves can form. Scientists have sent spacecraft through Earth's bow shock and recorded the oscillations. They've measured the frequencies, and when those frequencies are shifted into the range of human hearing, they sound like whistles, chirps, strange warbling tones that rise and fall. It's not sound, the waves aren't moving through air, but it's a vibration, a pattern, something that in another context would be sound. NASA's Voyager spacecraft have traveled farther than any human-made object. Launched in 1977, they've crossed the boundary of our solar system and entered interstellar space. And on their journey, they've been listening, not with ears, but with instruments designed to measure electromagnetic waves and plasma oscillations. In 2012, Voyager 1 crossed the heliopause, the edge of the sun's influence. Out there, the solar wind finally stops. The pressure from interstellar space pushes back. And at that boundary, Voyager detected something remarkable: a hum, a vibration in the plasma, a constant tone caused by oscillations in electron density. Scientists converted that vibration into sound, and what you hear is a low, steady drone, a note that rises slightly then falls. It sounds lonely, like the universe breathing in the dark. But again, it's not sound, it's a translation, a way of making the invisible audible. The actual waves are electromagnetic, traveling through plasma, too thin to carry traditional sound. But the pattern is there, the rhythm is there, and that's enough to give us something to hold on to. Supernovae create shock waves too. When a massive star dies, its core collapses in less than a second. The outer layers no longer supported fall inward. Then they rebound. The rebound sends a shock wave tearing through the star's outer shell, blowing it apart in a catastrophic explosion. That shock wave travels outward at a significant fraction of the speed of light. And as it moves, it plows into the surrounding space. If that space contains gas dust or plasma, the shock compresses it, heats it, creates a boundary where pressure and density spike. Within that boundary, waves can form, not sound waves, but pressure waves in the tenuous medium. Scientists studying supernova remnants have observed these oscillations. They've measured the density variations in the expanding shells of gas. And in some cases, they've estimated what those variations would sound like if they were happening in air. The Crab Nebula, the remnant of a supernova that exploded in 1054, is still expanding, still pushing outward. And within its glowing filaments, researchers have detected signs of turbulence, oscillations, patterns that suggest the nebula is in some abstract way ringing, like a bell that was struck 1,000 years ago and is only now beginning to fall silent. If you could hear it, scientists estimate it would be a deep rumble, lower than the lowest note on a piano, a vibration you'd feel in your chest more than hear with your ears. But you can't hear it, because between us and the Crab Nebula, there's vacuum, and vacuum doesn't care how beautiful the vibration is. It won't carry it. It won't pass it along. The nebula rings in silence, and we're left to imagine. Jupiter has a magnetosphere, a vast, powerful magnetic field that extends millions of miles into space. And within that magnetosphere, plasma waves dance. Scientists have known this since the 1950s, when radio telescopes first detected bursts of radio emission from Jupiter. Strange crackling sounds that seem to come from the planet itself. Those emissions are caused by plasma waves, charged particles spiraling along Jupiter's magnetic field lines, emitting radiation as they accelerate. When NASA's Juno spacecraft entered Jupiter's magnetosphere in 2016, it recorded those emissions up close. And when researchers converted them to audio, the result was otherworldly. Pops, hisses, a sound like static mixed with whale song. It's hauntingly beautiful and deeply strange. Because Jupiter, a planet without a solid surface, a planet made mostly of gas and liquid, is generating these sounds. Or rather generating the electromagnetic waves that we turn into sounds. The planet doesn't know it's making music. It doesn't care. But we hear it anyway. We translate its magnetic field into something we can understand. And in doing so, we give voice to a world that has none. Saturn does something similar. Its rings, vast and thin, are full of ice particles and dust. And those particles are electrically charged, affected by Saturn's magnetic field. When Cassini-NASA's spacecraft passed through the gap between Saturn and its rings in 2017, it detected oscillations, waves moving through the charged particles, a kind of plasma sound. Researchers converted those waves into audio, and what you hear is a crackling like rain on a tin roof, or distant thunder. It's the sound of ice particles colliding, charging, discharging, all orchestrated by invisible magnetic forces. Again, it's not sound, not in space, but it's close. Closer than we thought possible 100 years ago. Here's what fascinates me. The universe is full of these almost sounds, vibrations that don't quite qualify, waves that travel through media too thin to be called proper mediums, plasma humming, shock waves rippling, magnetic fields oscillating at frequencies we can measure but not hear. It's like the cosmos is trying to speak, not to us specifically, just speaking, because that's what systems under tension do. They vibrate, they release energy, they create patterns, and we, curious and stubborn, have found ways to listen. Not with our ears, which are useless in space, but with instruments, with mathematics, with the clever trick of translation. We take electromagnetic waves and shift their frequency down. We take plasma oscillations and convert them to pressure waves in air. We take data cold and numerical and turn it into something that resonates in our bones. It's a kind of magic. Or maybe it's just science doing what science does best. Finding connections, building bridges between the universe as it is and the universe as we can experience it. But we have to be careful, because these translations, these sonifications, they're not the real thing. They're interpretations, artistic choices wrapped in scientific data. And if we're not clear about that, we risk misunderstanding what space actually sounds like. Space sounds like nothing. That's the truth. The hard physical truth. But space contains vibrations, oscillations, patterns that if translated can sound like something. The difference matters, because one is reality, and the other is our way of making reality feel less alien. Still, there's beauty in the attempt, in the desire to hear what can't be heard, to give the universe a voice even if that voice is borrowed, even if it's ours projected outward onto a cosmos that never asked to sing. And maybe that's enough. Maybe the fact that we try, that we listen, that we translate and interpret and wonder, maybe that's what makes us human. We refuse to accept silence as the final word. We search for sound in the spaces between. And sometimes, just sometimes, we find it. Or something close enough to matter. What if I told you that you've already heard the universe singing, not in dreams, not in metaphors, but in actual recordings carefully crafted by scientists who refuse to let silence be the final answer? They took data from black holes and nebulae and distant planets. They translated light into sound, radiation into rhythm. They gave voice to things that have no voice. And the result is both beautiful and deeply strange, because these sounds are real in a way, and completely invented in another. This is the art of sonification, the practice of turning the unhearable into something we can experience. And it's changing how we understand the cosmos, one note at a time. In 2003, NASA released a recording that stopped people in their tracks. It was labeled "The Sound of a Black Hole." And when you listened to it, you heard a deep, resonant tone, the lowest note ever detected in the universe, B, flat 57 octaves below middle C, 57 octaves. That's a number so extreme it barely makes sense. If you tried to play that note on a piano, the keys would need to stretch across galaxies. The wavelength of the sound would be measured in light years. It's not a note you can hear. It's a note you can only comprehend mathematically. But NASA found a way. They were studying the Perseus galaxy cluster, a massive collection of galaxies bound together by gravity. At the center of that cluster sits a supermassive black hole, and astronomers noticed something odd. The hot gas surrounding the black hole showed ripples, pressure waves spreading outward in concentric circles like ripples on a pond. Those ripples were caused by the black hole itself. As it feeds, it releases energy. That energy pushes against the surrounding gas, creating waves. Compression and rarefaction over and over in a pattern that repeats every 10 million years. 10 million years per wave. That's not a sound any ear could detect, but it is a vibration. A real physical oscillation in the gas. And by measuring the spacing between those ripples, scientists calculated the frequency. B, flat. The deepest note in the known universe. Then they did something clever. They took that frequency and shifted it upward, not by 1 octave, not by 10, by 57 octaves until it reached a range humans can hear. And what emerged was haunting, a low, droning hum, almost melodic, almost mournful. People heard it and called it the sound of the black hole. Headlines declared that scientists had recorded the universe's music. But that's not quite right. The original vibration is real. The gas is really oscillating. But the sound you hear, that's a translation, a pitch-shifted version designed for human ears. It's like taking a book written in a language that uses wavelengths of light instead of letters and translating it into English. The meaning might be preserved, the essence might remain, but the form has changed completely. Does that make it less valid? Less true? I don't think so. But it does mean we need to be careful with our words. This isn't the sound of a black hole. It's a sonification of data collected from gas vibrations near a black hole. The distinction matters. Still, there's something profound about hearing it. Even knowing it's been altered, even understanding the layers of translation involved, it still feels like we're listening to something ancient, something real. A voice from the void made audible through mathematics and patience. NASA has done this with other objects too. In 2004, they released a sonification of the cosmic microwave background radiation. This is the leftover heat from the Big Bang spread across the entire sky in a faint glow of microwave light. It's the oldest light in the universe, a fossil from when everything was young and hot and dense. By itself, the cosmic microwave background is silent. It's light, not sound. Photons, not pressure waves. But it contains patterns, tiny fluctuations in temperature, places where the early universe was slightly hotter or slightly cooler. And those fluctuations correspond to sound waves that once traveled through the hot plasma of the infant cosmos. Scientists took those patterns and converted them into audio. They assigned different temperatures to different pitches. And what you hear is a crackling hissing sound, like static, like white noise. But buried in that noise are subtle variations, tones rising and falling, the echo of vibrations that happened 13.8 billion years ago. It's the oldest sound that ever existed. Or rather, it's a sonification of data that represents the oldest sound that ever existed. The original sound waves stopped being sound when the universe expanded and cooled, when the plasma turned into neutral gas and sound could no longer travel. But the pattern remained, frozen into the light. And now through technology and creativity, we can hear it again. Not as it was, but as a ghost. A memory translated into something our ears can comprehend. Some people find this moving. Others find it unsettling, because it forces us to confront a strange truth. The universe doesn't care about sound. It never did. But we care. We need to hear things to understand them. So we build tools to make the universe speak in our language. Jupiter's auroras are another example. On Earth, auroras are caused by charged particles from the solar wind hitting our atmosphere. They glow green and red and purple, painting the polar skies with light. But they also create radio emissions, electromagnetic waves that radiate outward as the particles spiral along magnetic field lines. Jupiter has auroras too, massive ones, brighter and more powerful than anything on Earth. And those auroras generate radio emissions at frequencies far above what humans can hear. NASA's Juno spacecraft has instruments designed to detect these emissions. And when scientists convert them to audio, the result is extraordinary. You hear whistles, chirps, rising and falling tones that sound almost like birdsong or whale calls. It's eerie, beautiful, completely alien. Those sounds are real in the sense that the electromagnetic waves are real, but they're not sounds in space. They're radio emissions translated down in frequency so we can experience them as audio. The pattern is there, the rhythm is there, but the medium has been changed. And that raises a question. If we're changing the medium, are we still hearing the universe? Or are we just hearing our own interpretation of the universe? Maybe both. Maybe that's the only way it can be. Saturn's rings have been sonified too. When Cassini dove between the planet and its rings in 2017, it detected faint oscillations, tiny variations in electromagnetic fields caused by charged ice particles moving through Saturn's magnetosphere. Those variations were converted to audio, and what you hear is a crackling like bacon frying, or rain on a metal roof. It's strangely comforting. This distant alien world making a sound that feels familiar. But again, it's not a sound Saturn makes. It's a sound we made from Saturn's data. The Voyager Golden Record is famous, a phonograph record attached to both Voyager spacecraft carrying sounds and images from Earth into the cosmos. Greetings in 55 languages, music from different cultures, natural sounds like thunder and whales and wind. It was meant as a message, a way of saying, here's who we are, in case anyone finds this. But what's less famous is that Voyager itself has been listening, recording the plasma waves it encounters, the oscillations in electron density, the hum of interstellar space. And some of those recordings have been converted to audio. What you hear is a low, steady tone, a vibration that rises slightly then falls. It sounds lonely, like a voice calling from farther away than you can imagine. That's the heliosphere, the bubble of influence our sun creates. At its edge where the solar wind meets interstellar space, plasma waves ripple. Voyager detected them, measured them, and now we can hear them translated into sound. It's not the universe speaking, but it's close. It's the universe vibrating, and we're listening in the only way we know how. Pulsars are another fascinating case. These are rapidly spinning neutron stars, the collapsed cores of dead suns. They emit beams of radiation from their magnetic poles, and as they spin, those beams sweep across space like lighthouse beacons. When a beam points at Earth, we detect a pulse, a flash of radio waves. Some pulsars spin hundreds of times per second. The pulses come so fast, they blur together. But when astronomers convert those radio pulses to audio, you hear a rhythm, a clicking, a pattern that's almost musical. The first pulsar ever discovered in 1967 was initially thought to be a signal from an alien civilization. Jocelyn Bell Burnell, the graduate student who found it, noticed the regular pulses and wondered if they were artificial. She even jokingly called it LGM1 for little green men. But further study revealed the truth. It was a pulsar, a natural object, a dead star spinning so fast it seemed impossible. And the pulses weren't a message. They were just physics, electromagnetism and rotation creating a pattern that our instruments could detect. When you listen to a pulsar's rhythm, you're not hearing sound. You're hearing a translation of electromagnetic pulses into clicks. But the pattern is real. The timing is real. And that's enough to feel like you're touching something out there. Scientists have even created musical compositions using pulsar data, taking the rhythms and pitches from multiple pulsars and layering them together. The result is strange, hypnotic, a kind of cosmic percussion, where each beat comes from a different dead star light years away. It's art, but it's also science, a way of experiencing data that's too abstract to visualize, a way of making the universe feel less distant. Here's the thing about sonification. It's not lying. The data is real. The measurements are accurate, but it is translating, and every translation involves choices. What frequency range to use, what instruments to assign, what pitch shifts to apply. Two scientists could take the same data and create two completely different sounds. Both would be valid, both would represent the same underlying reality, but they'd feel different, sound different, evoke different emotions. And that's where art meets science. Because sonification isn't just about accuracy. It's about communication, about taking something true but inaccessible and turning it into something people can connect with. When you hear the sound of a black hole, you're not hearing the black hole. You're hearing a carefully crafted interpretation of data from gas near the black hole. But that interpretation helps you understand. It gives you a sense of scale, of rhythm, of presence. It makes the abstract concrete, and in doing so, it brings the universe a little closer. Some scientists worry about this. They worry that sonifications mislead people, that they create false impressions of what space sounds like. And there's truth to that concern. If someone hears a NASA recording and thinks that's literally what you'd hear, floating next to a black hole, they've been misled. But most sonifications come with explanations, context, disclaimers that clarify what's been done. And for those who read or listen carefully, the truth is there. The real risk isn't misleading people. It's that we might forget to be amazed by the translation itself, that we might take for granted how incredible it is that we can do this at all, that we can take electromagnetic waves or pressure variations in gas or plasma oscillations and turn them into something beautiful. Because that's what we do. We build bridges between the universe as it is and the universe as we can experience it. And those bridges, imperfect as they are, let us cross. Let us explore. Let us feel like we belong out there, even though we're stuck down here. Do you ever wonder what other patterns are out there? What vibrations we haven't detected yet? What rhythms might be hiding in the data we haven't thought to sonify? The universe is full of oscillations, full of waves and pulses and cycles. Most of them we'll never hear even with translation. They're too slow, too fast, too faint, too strange. But every time we find one, every time we convert it to sound, we're adding another voice to the cosmic chorus. A chorus that was always singing even if no one was listening. And maybe that's the point. Not to claim we've heard the universe as it truly is, but to celebrate the fact that we tried, that we listened, that we found ways to translate silence into something that resonates in our bones. The universe may not have sound, but it has patterns. And patterns, when we're clever enough, can become music, can become meaning, can become a way of feeling less alone in the dark. And speaking of patterns of rhythms, we've learned to recognize there are moments when the universe's silence is broken in the most dramatic way imaginable. Not by sound, but by something else entirely. Something that shakes the fabric of space itself. Imagine the most violent event you can think of. An explosion so powerful it outshines entire galaxies. A collision so energetic it bends the fabric of space itself. A death so catastrophic it sends ripples across the universe, traveling at the speed of light for billions of years. Now, imagine all of that happening in complete silence. No roar, no echo, no sound at all. Just the visual fury unaccompanied by anything your ears could detect. That's the paradox of cosmic violence. The universe's most dramatic moments are also its quietest. And in that silence, there's something both terrifying and strangely peaceful. When a massive star runs out of fuel, it doesn't fade gently. It doesn't dim and cool like a campfire burning down to embers. Instead, it collapses. In less than a second, The core of the star, an object larger than Earth, compresses into something the size of a city. The pressure becomes unimaginable. Atoms are crushed. Electrons are forced into protons, creating neutrons. And the energy released in that collapse is beyond anything we have words for. The outer layers of the star, no longer supported by the core's heat and pressure, fall inward. They accelerate, faster and faster. And when they hit the incompressible neutron core, they bounce. That rebound sends a shock wave tearing outward through the star. And in a matter of hours, the star explodes. We call this a supernova, and it's one of the brightest events in the universe. For a few weeks, a single dying star can outshine all the other stars in its galaxy combined. Billions of suns dimmed by the light of one stellar death. The energy released is staggering. In the first 10 seconds of a supernova, more energy radiates outward than our sun will produce in its entire 10 billion year lifetime. If you could somehow capture all that energy and convert it to sound, if space were filled with air dense enough to carry it, the noise would be beyond comprehension. Scientists have tried to estimate what it would sound like. The numbers are almost meaningless. Decibel levels in the millions, billions. Sounds so loud it would tear apart anything nearby, not just damage your hearing, destroy you, vaporize you, turn you into plasma before you even registered the noise. But space is a vacuum, so none of that happens. The supernova explodes in perfect silence. The shock wave races outward. The light blooms. Neutrinos flood across the cosmos. And through it all, not a whisper. It's like watching the most spectacular fireworks display ever conceived through soundproof glass. You see everything, the colors, the expanding shell of gas, the shock wave plowing through interstellar space. But you hear nothing. Does that make it less violent, less real, or does it make it more profound? A reminder that violence doesn't need to announce itself, that destruction can be quiet, that the universe operates on scales where our human senses barely matter. In 1987, astronomers witnessed a supernova in the Large Magellanic Cloud, a small galaxy near our own. It was called SN 1987A. And it was the closest supernova to Earth in nearly 400 years. Close enough that neutrino detectors on Earth picked up the ghostly particles streaming outward from the dying star. Those neutrinos arrived hours before the light did. Because neutrinos barely interact with matter, they pass through planets, through stars, through entire galaxies, almost without noticing. While the light from the supernova fought its way through the star's outer layers, the neutrinos just left, straight through, unimpeded. When they reached Earth, a few dozen of them happened to collide with detectors. Tiny flashes of energy recorded by instruments designed for exactly this purpose. And in those flashes, scientists read a story. The story of a star's core collapsing, of neutrons forming, of energy being released in quantities that still make physicists pause, but no sound, not even close. The neutrinos carried information, but they didn't carry vibrations, and the vacuum between the Large Magellanic Cloud and Earth made sure no sound waves followed. SN 1987. A is still visible today, not the explosion itself which faded years ago, but the remnant, the expanding shell of gas glowing as it plows through the surrounding space. It's growing, cooling, slowly dispersing, and it's completely silent. Neutron stars are what's left behind after some supernovae. They're incredibly dense. A teaspoon of neutron star material would weigh about 1 billion tons on Earth. The gravity is so intense that the surface is smooth, almost perfectly spherical. Any mountains would be millimeters tall at most, crushed flat by the immense gravitational pull. And sometimes neutron stars collide. When two of them orbit each other, they lose energy to gravitational waves, slowly, over millions or billions of years. But eventually they spiral inward, closer and closer, faster and faster, until finally they merge. The collision releases more energy than 1,000 supernovae. The impact creates heavy elements like gold and platinum forged in the extreme conditions of colliding neutron matter. It sends gravitational waves rippling across space-time, distorting the very fabric of the universe. And it happens in silence. Perfect, absolute silence. On August 17, 2017, scientists detected gravitational waves from just such a collision. The signal came from a galaxy called NGC 4993, about 130 million light-years away. Two neutron stars had spiraled into each other, and for the first time in history, humans detected both the gravitational waves and the light from the same event. It was a breakthrough, a new way of observing the universe. Gravitational wave astronomy combined with traditional telescopes. Scientists learned more about neutron star collisions in those few days than they had in decades of theorizing. But here's what strikes me. The collision itself, the moment when two objects each weighing more than our sun, smashed together at a significant fraction of the speed of light, releasing energy that briefly outshone their entire galaxy. That moment was silent. The gravitational waves aren't sound. They're ripples in space-time distortions in the geometry of the universe itself. When LIGO, the Laser Interferometer Gravitational Wave Observatory, detected them, it measured changes in distance smaller than the width of a proton, impossibly tiny, stretching and squeezing of space. Scientists converted those ripples into audio, and what you hear is a chirp, a rising tone that lasts about 1/10 of a second. It sounds almost playful, like a bird calling or a door creaking open. But it's not sound, it's a translation, a way of experiencing data. The actual gravitational waves don't make noise, they can't. Sound is a mechanical wave. Gravitational waves are something else entirely. Still, that chirp has become iconic. People call it the sound of two neutron stars colliding. And in a way it is, just not literally, not physically. But as a representation, as a way of understanding what happened, it works. It gives us something to hold on to. A way of feeling the event, not just seeing it in graphs and equations. Galaxies collide too. Not often. Space is so vast that even when two galaxies pass through each other, most of the stars never touch. They just drift past like two swarms of bees flying through each other without collision. But over time, gravity does its work. The galaxies slow down, circle back, pass through again. And eventually, if they're the right size and moving at the right speed, they merge. Billions of stars mixing together, gas clouds compressing, new stars forming from the collision-triggered collapse of interstellar gas. The process takes millions of years, hundreds of millions. It's slow by human standards, but violent by cosmic ones. Star formation rates spike. Supermassive black holes at the centers of each galaxy eventually spiral together. The entire structure of both galaxies gets rearranged, and through it all, silence. Despite billions of stars moving, despite gas clouds compressing and heating, despite black holes merging at the climax of the collision, silence. Our own Milky Way is on a collision course with the Andromeda Galaxy. In about 4.5 billion years, they'll begin to merge. The night sky will change. Andromeda will grow larger and larger until it dominates the view. Stars will pass uncomfortably close. Some might even be ejected from both galaxies, flung into intergalactic space by gravitational interactions. But no one will hear it. If humanity is still around, if we're still on Earth or somewhere nearby, we'll watch it happen in silence. The most dramatic astronomical event in our galaxy's history. And it will unfold without a single sound. There's something humbling about that. The idea that the universe's greatest spectacles don't need sound. That they happen anyway, regardless of whether anyone can hear them. It makes you wonder what we're missing. What other events are unfolding right now in distant corners of the cosmos that we'll never detect because they don't produce light or gravitational waves or any signal we know how to measure? The universe is full of things we can't see, can't hear, can't detect, and it doesn't care. It keeps happening anyway. Black holes are perhaps the ultimate example of silent violence. When matter falls into a black hole, it accelerates. It heats up. It spirals inward, forming an accretion disk that glows brighter than stars. And as it crosses the event horizon, the point of no return, it disappears. Gone. Lost to the universe forever. That final moment when matter crosses the horizon and enters the black hole is silent. There's no sound, no flash, no signal we can detect. It's just gone. And yet the amount of energy involved is staggering. Matter falling into a black hole releases more energy per unit mass than any other process in the universe. More than fusion, more than fission, more than antimatter annihilation. The efficiency is unmatched. If we could harness that energy, we could power civilizations for billions of years. But we can't, because it happens inside the event horizon, inside a place where the laws of physics as we understand them break down, where space-time is so warped that nothing, not even light, can escape. Silent, powerful, unreachable. Sometimes I think about what it would be like to witness these events up close. Not close enough to be destroyed, but close enough to really see them, to float in space protected somehow and watch a supernova unfold, to see the shockwave expanding, the light brightening, the star tearing itself apart, and to hear nothing, just your own breath, your heartbeat, the quiet hum of whatever technology is keeping you alive. Would it feel wrong, incomplete? Or would the silence make it more powerful, more real? I think it might be the latter, because sound in a way is a distraction. It gives us something to react to, something to process. But silence forces us to just watch, to witness, to absorb the enormity of what's happening without the buffer of noise. The universe doesn't perform for us. It doesn't care if we're impressed. It just does what it does. Stars explode. Black holes merge, galaxies collide, all in the quiet dark, all without fanfare. And maybe that's exactly how it should be. Maybe the silence is part of the beauty, part of the lesson. Because violence doesn't need to be loud to be real. Destruction doesn't need to announce itself. The universe is full of catastrophes happening right now in perfect silence. And they're no less real for being unhearable. In fact, maybe they're more real, because they don't depend on us. They don't need us to hear them. They just are. And we, tiny and curious, floating on a small rock in a vast ocean of nothing, we found ways to witness them anyway, to detect their light, to measure their gravitational waves, to piece together what happened even though we'll never hear the sound. That's remarkable, in its own quiet way. But there's one place where humans have experienced something close to this cosmic silence, a place where the void presses in, where technology is the only thing standing between you and the endless quiet. And the people who've been there, the ones who floated in that silence, they have stories that might change how you think about sound itself. There are only a few hundred people in all of human history who know what true silence feels like. Not the quiet of a library, not the stillness of a winter night, but the kind of silence that presses against you, that surrounds you completely, that reminds you with every breath how far you are from everything you've ever known. Astronauts live in that silence. They float in it, work in it, sleep in it. And when they come back to Earth, many of them say the same thing. Space wasn't what they expected, not because of what they saw, but because of what they didn't hear. And that absence, that profound quiet, changed them in ways they're still trying to explain. Chris Hadfield spent nearly 5 months aboard the International Space Station in 2013. He's a pilot, a musician, someone who's comfortable with noise, with engines roaring, with the controlled chaos of flight. But when he performed his first spacewalk, stepping outside the ISS into the void, he described it as the most peaceful moment of his life. Not because nothing was happening. The ISS was racing around Earth at 17,500 miles per hour. The sun was blazing. The planet was turning below him. Everything was motion. Everything was energy, but there was no sound, none. Just his breath inside the helmet, the soft hiss of oxygen flowing through the life support system. And beyond that, nothing. An absence so complete it felt almost physical. He said it was like meditation, forced meditation, because you can't escape the silence. You can't turn on music, can't call someone, can't fill the void with distraction. You're alone with your thoughts in a way that's impossible on Earth. And for some astronauts, that's terrifying. For others, it's transcendent. Inside a spacecraft, things are different. The ISS is noisy. Fans whir constantly circulating air. Pumps hum moving coolant through the systems. Equipment beeps. Laptops chime. And there's a constant low-frequency vibration. The sound of machinery keeping humans alive in an environment that wants them dead. Astronauts describe it as white noise, background hum, the kind of sound you stop noticing after a while. But it's always there. A reminder that between you and the vacuum is just a thin shell of metal and technology. Scott Kelly spent nearly a year on the ISS, 340 days. And he said one of the hardest things to adjust to was the noise inside and the silence outside, the contrast, the dissonance. Because your brain expects consistency. When it's loud here, it should be loud there. When it's quiet inside, it should be quiet outside. But space doesn't work that way. You can be surrounded by machines, by noise, by the mechanical symphony of survival. And then you look out the window, and you know that just beyond that glass, there's nothing. No sound, no air, just void. It messes with you, in subtle ways. Kelly talked about dreams where he could hear things in space, explosions, voices, music, his subconscious trying to fill in what was missing, trying to make sense of a world where sight and sound don't match. Because we're wired for sound, our brains use it to navigate, to understand our environment, to feel safe. And when sound is taken away, when half of our sensory input goes silent, something shifts. Some astronauts find it peaceful, a break from the constant noise of Earth, but others find it unsettling, lonely, a reminder that they're in a place humans were never meant to be. During a spacewalk, you hear your own body in ways you never do on Earth. Your heartbeat becomes loud, noticeable. Each breath sounds amplified inside the helmet. And because there's no other sound to compete with it, no traffic or wind or voices, your body becomes the soundtrack. Some astronauts say it's calming, grounding, a way of staying present. Others find it claustrophobic, like being trapped inside yourself. Peggy Whitson, who holds the record for most time spent in space by a NASA astronaut, described hearing her own breathing as both comforting and eerie. Comforting because it meant she was alive. The suit was working. Everything was okay, but eerie because it was the only sound, the only proof of existence in an otherwise silent universe. She talked about moments during spacewalks when she'd pause, just stop moving, float, and listen to nothing, to the absence. And she said it felt like standing at the edge of something vast, not a physical edge, a psychological one, a place where the mind has to confront how small it is, how fragile. And in that confrontation, some people find peace, others find fear, most find both. There's a phenomenon astronauts talk about called the overview effect. It's the cognitive shift that happens when you see Earth from space, not as a map, not as countries and borders, but as a whole, a fragile blue sphere floating in darkness. Many astronauts say the silence amplifies that effect. Because when you're looking at Earth, this beautiful living world, and you're surrounded by absolute quiet, the contrast is overwhelming. Life down there is loud, chaotic, full of motion and sound and energy. But up here where you are, it's silent, still. And that stillness makes the noise of Earth feel even more precious, more miraculous. Frank Borman, who flew on Apollo 8, the first mission to orbit the moon, described looking back at Earth and feeling a profound sense of isolation. Not because he was alone, his crewmates were right there, but because Earth looked so small, so distant, and the silence around them made that distance feel infinite. He said it was the loneliest he'd ever been, not in a sad way, in an existential way. A reminder that everything he'd ever known, everyone he'd ever loved, every sound he'd ever heard, all of it was on that tiny blue dot. And he was out here, in the quiet, separated by a gulf that felt bigger than just physical space. On the moon, the silence is even more profound, because there's no atmosphere at all, not even the thin traces you find in low Earth orbit, just solid ground beneath your feet and vacuum above your head. When Neil Armstrong and Buzz Aldrin stepped onto the lunar surface. In 1969, they moved through a world that had never known sound. Every footstep they took, every rock they disturbed, every motion they made, it all happened in silence. They could hear themselves inside their suits, the hiss of oxygen, the whir of fans, the crackle of the radio when mission control spoke. But outside, nothing. The moon didn't care that humans had arrived. It didn't react, didn't echo, didn't respond. Buzz Aldrin later described it as surreal, because the moon looked like a place, like a landscape. Your brain expected it to sound like a place too. Expected wind or creaking or the ambient noise of an environment, but there was none of that. Just visual presence and auditory absence. And that mismatch created a feeling he couldn't quite name. Not fear, not awe, something in between, something that made him feel like he was in a dream. Other Apollo astronauts reported similar experiences. Gene Cernan, the last person to walk on the moon, talked about standing in the Taurus Littrow Valley and just listening to the silence. He said it felt ancient, like the moon had been waiting in that silence for billions of years. And now, for a brief moment, humans were there to witness it. But the moon didn't change. It stayed silent, patient, indifferent. And when the astronauts left, the silence returned, as if they'd never been there at all. Inside the lunar module, the sounds were mechanical. Pumps, fans, the occasional beep from the computer. But those sounds felt intrusive, like they didn't belong, because outside through the small windows, you could see a world that had never heard anything. And bringing noise into that world felt almost disrespectful. Alan Bean, who walked on the moon during Apollo 12, described feeling like he was in a cathedral, not because it was sacred in a religious sense, but because it demanded reverence, demanded quiet. He said that even though they talked to each other, even though mission control was constantly in their ears, there was still a sense of silence underneath it all. A silence that couldn't be filled, couldn't be covered up. A silence that was older and deeper than anything humans could create. Have you ever been somewhere so quiet that you could hear your own pulse, where the absence of sound became its own kind of presence? That's what astronauts describe, not just the lack of noise, but the way silence fills space, the way it becomes something you notice, something you feel. On Earth, true silence is almost impossible. There's always something. Wind rustling leaves, distant traffic, the hum of electricity in the walls, your own heartbeat and breath. Even in the quietest room, there's sound. But in space, especially during a spacewalk, you can get close to true silence. And astronauts say it changes you, not dramatically, not overnight, but slowly, gradually. It shifts how you think about noise, about presence, about what it means to exist. Samantha Cristoforetti, an Italian astronaut who spent 200 days on the ISS, talked about missing the sounds of Earth, rain, birds, wind through trees. She said she didn't realize how much those sounds anchored her until they were gone. In space, there's no weather, no seasons, no natural soundscape, just the mechanical hum of the station and the silence beyond. And that absence made her homesick in a way she hadn't anticipated. Not homesick for people necessarily, but homesick for the sounds of a living planet, for the auditory texture of Earth. She said when she returned, the first thing she noticed was how loud everything was. Cars, voices, music, wind. It was overwhelming. almost painful. Her brain had adjusted to the quiet, and coming back to a world full of sound felt like sensory overload. Other astronauts report the same thing. After months in space, Earth feels too loud, too chaotic. It takes time to readjust, to remember that this is normal. That sound is supposed to fill the air. But some part of them, a small, quiet part, misses the silence, misses the stillness of floating in the void where the only sound is your own breath. There's something else astronauts mention, something subtle. When you're in space surrounded by silence, you become more aware of the sounds you do make, your voice, your movements, the way your tools clink against metal, because there's no background noise to blend into, no ambient sound to hide in. Every noise you make stands out, becomes distinct, almost too loud, and that makes you more careful, more deliberate. You move quietly not because you have to, but because it feels right. Because adding noise to the silence feels intrusive. It's a strange kind of politeness, being respectful to the void, to the emptiness that surrounds you. Yuri Gagarin, the first human in space, described looking at Earth and feeling an overwhelming sense of fragility. He saw how thin the atmosphere was, how delicate, and he realized that everything that makes sound, everything that lives, everything that breathes, it's all contained in that thin blue shell. Outside of it, nothing, silence, emptiness. And that realization, that understanding of how rare and precious sound is, it stayed with him. He talked about it for years afterward, how being in silence made him appreciate noise, made him appreciate life. Because life is loud, it's chaotic and messy and full of sound, and that's beautiful. That's what makes it alive. Silence, for all its peace, for all its stillness, is the domain of the lifeless, of the void, of places where nothing breathes. Astronauts live in both worlds, the loud machinery of survival and the silent void beyond. And navigating between those worlds, staying sane in that contrast, it requires a kind of mental flexibility most people never develop. But those who do, those who spend months floating in that silence, they come back changed, not broken, not traumatized, but different, quieter in some ways, more thoughtful, more aware of the sounds around them. They've touched the silence, and it's touched them back. And maybe that's the real gift of going to space, not just seeing Earth from a new perspective, but hearing it, or rather hearing its absence, and understanding in a way that words can't quite capture how rare and miraculous it is to live somewhere that makes sound at all. Yet even as astronauts float in that profound quiet, even as they experience the silence of the void, there's a question that lingers, a question that philosophers and scientists have wrestled with for centuries. What does silence really mean? And why, despite all its peace, does it sometimes feel so heavy? If a star explodes in the void and no one is there to hear it, does it make a sound? It's an old question rephrased, the kind that philosophers love and scientists try to avoid. But it matters because the answer reveals something profound about reality itself, about what exists independently of us and what only exists because we're here to witness it. The universe is silent. We know that now. But what does that silence mean? Is it empty, or is it full of something we haven't learned to name yet? And why, when we think about the vastness of space, does that silence feel so heavy? In 1710, a philosopher named George Berkeley published a thought experiment that would haunt thinkers for centuries. He asked a simple question. If a tree falls in a forest and no one is around to hear it, does it make a sound? Most people instinctively say yes. Of course it makes a sound. The tree hits the ground. Air molecules vibrate. Sound waves propagate outward. The physics happens whether anyone's listening or not. But Berkeley argued differently. He suggested that sound as we understand it is a subjective experience. The vibrations exist, the pressure waves exist, but sound, the actual perception of noise, only exists in the mind of an observer. Without ears, without a brain to interpret the vibrations, there is no sound, just physics, just waves moving through a medium. It's a semantic argument in some ways, a matter of definitions, but it touches on something deeper, the difference between what's objectively real and what's experientially real. And when we apply that thinking to space, to the silence of the cosmos, it gets even stranger. Because out there, the vibrations don't even exist. The medium is missing. So not only is there no observer to hear, there's nothing to hear in the first place. Space isn't a tree falling unheard. It's a tree that can't fall at all. And yet, we talk about the sound of space. We create sonifications. We translate data into audio. We give voice to the voiceless. Why? What are we trying to do? Maybe we're trying to make the universe feel less alien, less distant. Because sound is intimate. It's how we connect, how we communicate. A universe without sound is a universe we can't talk to, can't hear from, can't relate to in the way we relate to each other. So, we build bridges. We turn electromagnetic waves into audio. We shift frequencies until they match what our ears can detect. And we call it the sound of Jupiter, the sound of a black hole, the sound of the cosmos. But it's not really. It's our sound, our interpretation, our need to hear something projected onto a universe that never asked to speak. Is that dishonest, or is it human? I think it's human, beautifully necessarily human. There's a concept in philosophy called the anthropic principle. It comes in different forms, but the basic idea is this. The universe appears fine-tuned for life because if it weren't, we wouldn't be here to observe it. The fact that we exist constrains what kind of universe we can inhabit. Sound is part of that. We evolved on a planet with an atmosphere, a thick, vibrant ocean of air that carries vibrations beautifully. Our ancestors needed to hear predators, to communicate danger, to find each other in the dark. So, we developed ears, sophisticated sensitive organs that turn pressure waves into electrical signals our brains can interpret. And because we evolved with sound, we think in sound. We use it to navigate the world, to understand space and distance, to feel safe. But the universe doesn't care about that. The universe is mostly silent, mostly empty, mostly indifferent to whether life evolves or not. We're the exception, the rare pocket of noise in an otherwise quiet cosmos. And maybe that's exactly the point. Because silence isn't absence. Not really. It's potential. It's space for something to happen. A canvas waiting for sound to be painted on it. Earth is that painting. A world where molecules are close enough to carry waves. Where life is loud enough to fill the air with bird song and thunder and laughter. Where sound exists because the conditions allow it. And we products of that noisy world, we bring sound with us wherever we go. In our spacecraft. In our suits. In our recordings and translations and desperate attempts to make space speak. We can't help it. Sound is how we understand existence. Carl Sagan once said that we are a way for the cosmos to know itself. And maybe sound is part of that knowing. Not the universe's sound, but ours. The noise we make as we explore, as we measure, as we try to comprehend something vastly larger than ourselves. We give voice to the stars because we need to hear them. And in doing so, we learn not just about the stars, but about ourselves. About what we value, what we fear, what we long for. Silence to us feels like loneliness, like isolation. Because we're social creatures, we thrive on connection. And sound is one of the primary ways we connect. When someone speaks to you, their voice creates vibrations that travel through air and vibrate your eardrum. Those vibrations become neural signals, and in your brain, meaning emerges. You hear not just noise, but intention, emotion, presence. Sound is how we know we're not alone. So, when we look at space vast and silent, we feel alone, even though we're surrounded by stars. Even though galaxies sprawl in every direction, the silence makes it feel empty, makes us feel small. And maybe that's why we're so drawn to the idea of extraterrestrial life. Not just because we want to know if others exist, but because we want to hear them. We want a voice in the darkness, a signal that says, "You're not alone. We're here too." The search for extraterrestrial intelligence SETI is really a search for sound. Not literal sound, but radio signals. Patterns in the electromagnetic spectrum that suggest intentionality, communication, someone trying to be heard. We've been searching for decades, listening to the sky with massive radio telescopes, scanning frequencies, looking for anything that doesn't fit the random noise of the cosmos. And so far, we've heard nothing. Just the natural emissions of stars and pulsars and black holes. Patterns, yes, but not messages, not meaning. The universe remains silent, and that silence weighs on us, because silence in human experience often means absence. It means no one's home, no one's listening, no one cares. But what if we're wrong about that? What if silence doesn't mean absence? What if it's just a different kind of presence? The Quakers have a practice called silent worship. They gather in a room and sit quietly. No sermon, no music, no words, just people together in silence. And they say that silence isn't empty. It's full of thought, full of presence, full of connection that doesn't need words. Maybe the universe is like that. Silent, but not empty. Present, but not loud. We just have to learn how to listen differently. Not with ears, but with instruments, with mathematics, with patience. In Zen Buddhism, there's a concept called maya. It's often translated as negative space, the silence between notes in music, the emptiness between objects in a painting, the pause between breaths. Ma isn't absence, it's structure. It's what gives form to the things around it. Without silence, music would be noise. Without space, objects would blur together. The silence of the cosmos might be like that. Not a lack, but a structure. The framework that allows stars to exist, galaxies to form, light to travel. If space were full, if it were packed with matter dense enough to carry sound, nothing would work. Stars couldn't shine clearly. Galaxies couldn't move. Light would scatter and fade. The vacuum isn't a problem, it's the solution. And the silence that comes with it. Maybe that's the solution too. Maybe the universe needs to be quiet so that the things within it can be loud. There's a piece of music by John Cage called 433. It's 4 minutes and 33 seconds of silence. Or rather, it's a piece where the musician doesn't play their instrument at all. When it premiered in 1952, people were confused, angry even. They had paid for a concert and the pianist just sat there, silent. But Cage's point was that silence doesn't exist. Not really. During those 4 minutes and 33 seconds, the audience heard rain on the roof, wind through the trees, people shifting in their seats, breathing, coughing. The absence of intentional music didn't create silence. It revealed all the other sounds that are always there. The ambient noise of existence. Space is like that in a way. We call it silent. But it's full of things. Radiation, particles, gravitational waves, magnetic fields oscillating, plasma vibrating. It's not sound, but it's not nothing either. And when we listen carefully, when we use the right tools, we find that the universe is communicating, just not in a language our ears understand. Maybe that's the real lesson. That communication doesn't require sound. That presence doesn't require noise. That the universe is here vast and ancient and full of energy, and it's been here all along. We just had to stop expecting it to speak our language and start learning to speak its. Do you ever sit in silence, real silence, or as close as you can get, and just listen to what emerges? It's uncomfortable at first. The mind wanders. You become aware of every little sound, your heartbeat, your breath, the hum of electronics. But if you stay with it, something shifts. The silence becomes less empty, more textured. You start to notice patterns, rhythms, the way your breath synchronizes with your pulse, the way ambient sounds rise and fall. Silence stops being absence and starts being presence. That's what astronauts describe, that shift from feeling lonely in the quiet to feeling held by it, surrounded by something vast and patient. The silence of space isn't rejecting us, it's just being itself, ancient, endless, unchanging. And we brief and loud, we're learning to exist within it, not by changing it, but by changing ourselves. By learning that silence isn't the opposite of sound, it's the space that makes sound possible. On Earth, we fear silence. We fill every moment with noise, music, television, conversation, anything to avoid the quiet. But maybe that's because we've forgotten what silence is for. It's not emptiness waiting to be filled. It's rest. It's stillness. It's the pause between breaths that makes breathing possible. The universe is silent because it doesn't need to prove it exists. It just is. Vast and patient and full of stars. And we, tiny and temporary, we get to witness it. Not by making it speak, but by learning to appreciate its quiet. Because in that quiet, in that profound cosmic silence, there's a kind of peace. A reminder that not everything needs to be loud to matter. That presence doesn't require performance. The universe is here. It's always been here. And it will be here long after we're gone. Silent, patient, waiting for nothing. And maybe that's the most beautiful thing about it, that it doesn't need us, doesn't need our noise or our interpretations or our attempts to make it familiar. It's just itself, forever. And as we float through all this contemplation, all these questions about sound and silence and meaning, there's one final place we need to go. One last thought to explore before we let the quiet settle in. Because understanding why the universe is silent changes how we think about our own voices, our own noise, our own brief, beautiful moment of sound in the endless dark. We are sound. That's the strange truth we've been circling this whole time. In a universe that's mostly silent, mostly empty, mostly indifferent to vibration, we are the ones who make noise, who speak, who sing, who fill the air with meaning. And maybe that's not a coincidence. Maybe that's the entire point. We evolve from silence. We emerge from the quiet dark. And for a brief, brilliant moment, we get to be loud, to matter, to echo through the void before returning to the stillness we came from. This is where our journey ends, not with answers, but with wonder, not with noise, but with the kind of peace that only comes from understanding. There's a photograph taken by Voyager 1 in 1990. It's called The Pale Blue Dot. From nearly 4 billion miles away at the edge of our solar system, the spacecraft turned its camera back toward home. And there, caught in a beam of scattered sunlight, was Earth, a single pixel, barely visible, so small you could miss it if you weren't looking. Carl Sagan wrote about that image. He talked about how everyone who ever lived, every human who ever spoke or sang or cried or laughed, everyone who ever made sound lived on that tiny dot. Every empire, every war, every symphony, every conversation, all of it contained in a speck of light suspended in the darkness. And around it, silence. Vast, patient, eternal silence. That image changes people because it puts everything in perspective. All our noise, all our drama, all the sounds we think are so important, they're happening on this fragile island of air. This thin shell around a rock floating in an ocean of nothing. Beyond our atmosphere, the universe doesn't hear us, doesn't care. Our loudest shouts, our most beautiful music, it all dies a few miles up, absorbed by the vacuum, lost to the void. And yet, we keep making sound anyway. Not because the universe needs it, but because we do. Sound is how we know we're alive, how we connect, how we transform thought into something another person can receive. It's miraculous when you think about it. You have an idea, a feeling, something abstract and internal. And by vibrating your vocal cords, by shaping air with your mouth and tongue, you can transfer that idea into someone else's mind. It's a kind of magic, ancient, ordinary, extraordinary. And it only works because we live in a place where molecules are close enough to carry the message, where air exists, where pressure can become pattern. We won the cosmic lottery, not just to be alive, but to be alive somewhere loud, somewhere that allows communication, connection, community. Most of the universe will never know sound, will never experience the intimacy of hearing another's voice, the comfort of familiar noise, the beauty of music resonating in a space designed to hold it. But we do. We get that. For as long as we're here. In 2012, NASA's Voyager 1 crossed the heliopause. It left the protective bubble of our sun's influence and entered interstellar space. True deep space. The kind between stars. And in that crossing, it measured something remarkable. The density of particles dropped. The plasma waves changed frequency. The cosmic ray intensity increased. Everything shifted. Voyager sent the data back, and scientists realized something profound. The spacecraft had entered a quieter realm, a place where even the faint plasma vibrations of the heliosphere were gone, where the universe was closer to its default state, empty, still, silent. Voyager is still out there, still traveling, still sending back faint signals when it can. But it's moving through silence now, through a darkness so complete, so vast, that it makes our solar system seem crowded by comparison. And one day, maybe millions of years from now, Voyager will encounter something, another star, another solar system, or it won't. It'll just keep drifting, forever, silent, alone. But it carries something with it, the golden record, a message from Earth, sounds and images encoded on a disc of gold-plated copper, music, greetings, the sound of wind and wails and laughter. It's a message in a bottle, thrown into the cosmic ocean, not because we expect anyone to find it, but because we needed to send it anyway, to say we were here, we made sound, we mattered. Even if no one ever hears it, the gesture matters. The act of reaching out into the silence and saying hello, we're here. Do you hear us? Because that's what humans do. We refuse to accept silence as the final word. The Apollo missions ended in 1972. The last humans walked on the moon. And then we stopped. Budget cuts, shifting priorities. The political will to explore faded. But the moon is still there, still silent, still waiting. And every piece of equipment we left behind, every footprint pressed into the regolith, every flag planted in the dust, it's all still there, unchanged, frozen in time. Because the moon has no weather, no wind, no erosion, just vacuum and silence. The footprints Neil Armstrong made in 1969, still there, sharp, clear, as if he walked away yesterday. They'll last for millions of years, maybe longer, until micrometeoroids slowly blur them, or until the sun expands and swallows the moon entirely. But for now, they're a record. Proof that humans came, that we walked, that we disturbed the ancient silence just for a moment. And then we left, and the silence returned. There's something poetic about that. About making a mark in a place that can't hear you, that doesn't acknowledge your presence, but the mark remains anyway. Maybe that's what all human endeavor is, making marks in the silence, creating meaning in a universe that doesn't require it, singing into the void not because anyone's listening, but because the singing itself is worthwhile. We've talked about silence as if it's a problem, something to overcome, something that makes the universe feel lonely. But what if silence is a gift? What if it's the universe's way of giving us space, room to breathe, room to think, room to create our own noise without interference? On Earth, we crave quiet. We pay for it. Build soundproof rooms, travel to remote places, seek meditation retreats where silence is the main offering. Because in silence, we find clarity, peace, the ability to hear our own thoughts without distraction. Maybe the universe has that clarity, that peace, and we loud and chaotic, we bring the noise. We bring the distraction, the drama. And that's okay. That's our role, to be the part of the universe that sings. But every song needs silence. Every note needs space around it. Without silence, music becomes noise. Without pauses, speech becomes gibberish. The silence of space isn't our enemy. It's the canvas, the stage, the quiet that makes our noise meaningful. When you think about it, we're incredibly lucky. We exist in a universe vast enough to be humbling, but structured enough to be knowable, silent enough to make us appreciate sound, but full enough of patterns to keep us curious. We get to experience both, the noise of Earth and the silence of space, the intimacy of voices and the vastness of the void. And in navigating between those extremes and learning to appreciate both, we become something more than just observers. We become participants, part of the story the universe is telling, a story that doesn't need sound to be profound, but is made richer, more beautiful, more human, because we found a way to give it voice anyway. So what do we take from all this? From our journey through silence and sound, through vacuum and vibration, through the physics of waves and the philosophy of meaning. Maybe this: sound is temporary, silence is forever. But that doesn't make sound less valuable. It makes it more precious, more worth celebrating. Every conversation you have, every song you hear, every laugh you share, it's all happening in a tiny bubble of air on a small planet in a vast, silent universe. And that makes it miraculous. Not ordinary, not mundane, miraculous. We are sound born from silence, returning to silence. And in between, we get to make noise, to communicate, to connect, to matter. Not to the universe. The universe doesn't need our noise, but to each other, to ourselves, to the brief, beautiful moment of existence we're lucky enough to experience. Tonight, when you're drifting towards sleep, maybe think about that. About the silence that surrounds us, about how rare and wonderful it is to live somewhere that allows sound to exist at all. And maybe appreciate the quiet a little more. Not as emptiness, but as the space that makes everything else possible. The universe is silent. It always has been. It always will be. But we're not. We're here. We're loud. We're alive. And for now, for this brief moment in cosmic time, that's enough. Thank you for drifting with me through this quiet night, for listening to these thoughts about silence and sound, about space and meaning, about the strange and beautiful fact that we exist at all. I hope you found some peace in these words, some wonder, some reason to look up at the stars and feel connected even in their silence. Sleep well, friend. Dream gently. And remember, in the quietest dark and the deepest silence, you are never truly alone. Because somewhere across the void, other minds are wondering too. Other voices are whispering into the night. Other hearts are beating in the cosmic stillness. We're all sound together, all noise in the void, all temporary, all precious. Good night, and until we drift together again, may you find beauty in both the noise and the silence, in the sounds of earth and the quiet of the stars. Rest now. The universe will still be here when you wake, silent, patient, eternal, waiting for nothing, giving us everything. Sweet dreams.